plain, but when you just say new file, it opens not this file, and you see that in the corner, there is the video. I do apologize. The important thing is hidden. So probably here you can see better. I can also close the other thing. I can just open the tutorial part. So we have done already Python. So you see, then I will open again, but you see that it is this page, and you see here in this position, but in your computer is more visible, this is run. If the name of the file does not ends with a .py, there is not this run. It is all the same, but without the run. So it is not useful. Any questions so far? Can you open? Did you open already? Thank you so much. I will just show to you that this environment calculates something at the beginning, just saying print. That is the common instruction in order to print the results, and then we can say 2 plus 2. And then run. Obviously, okay. There is an issue that is common when you use, is that when you run, you use a console. Since it is free, it is limited the number of consoles. That is 2. I have already reached the limit, so I just click here, and with the right, I put the consoles in another tab. Go here. I'm killing the console, so I have a console that is available for my calculation here. Hopefully, it is 4. Hopefully. Oh, there are many things. Oh, then, 4. So we have done the first calculation. 2 plus 2, it is 4. So we can use for just for this calculation. But in general, we don't use in this way, so a calculator. And you see that the same instruction that you put in the white part, you can put also in the black part, that is the output of the console. So you can say here 2 plus 2, it is 4, and 5 times I don't know, 9, it is 45. So calculate. So you can use as a calculator. But the typical way is that we assign, and so we can speak about types. I need to find a symbol here, as usual. And there is this piece of symbol that you see the symbol there. It is just the can you see? I don't know if it is visible or not. I don't know if I can also increase a little bit this. Can you see better? That symbol? How do you call this? That symbol? It is a symbol that is used by Python in order to comment. So we can say dash, okay? So this is the types, so we can say types, and then I will decrease a little bit this environment, try to not to make the thing very bad. And then we can say A equal, for example, to 4, and if we do this, we can print the type of A, and if we run, I can do also in the black part, but I do apologize. So I'm saving, I'm going back. Test. Okay. So you see here that the class is integer, but of course we can put the equal to 2 point, for example, 1, and print the type of B, and run or doing this. It is a floating number, can be also complex, that is more useful for our, so we can say C equal, for example, 1.5 plus 0.5J. This J gives the fact that this is a complex number, so if you print the type of this C, you see that it is considered to be complex. If I can also press here and see C, and you see that there is the complex number with the real part, the imaginary part. So in order to put the imaginary part, you need to write the number with a J, not I, but J. J is the root of -1, no? It is this. There are also other types, Boolean and so on. We can say this. I would like to show to you some containers, and then that is a list. I put here something that it is not so useful, but just an introduction. It is in order to show to you containers, the list. So I will put the colors, but it can be also numbers, numbers or everything. And in order to do the containers, you need to open the bracket, and then we can print our names of the colors. For example, I don't know if this is the correct character or this. Probably this. It is red. And then, for example, blue, green, black, white, as many as you wish. Then we can close this, and then we can print the type. Print the type of colors. We can also print the second color. So I want to print the name of the second color. We can also print the colors -1. So what do you imagine to happen when probably there is an error, so nothing happens. But indeed here you see that the type is a list. So this is a list. What is a list in Python? It is just a connection of elements. Colors, so can be numbers. In our case, it will be numbers, no? And just divided by a comma. It is important to have the brackets. And you see that you can also identify which is the element. And the second element, the third element, the last element of our list. And you have seen that I put here colors bracket, in bracket the indicator, which is the element, I put 2. And the answer here is green. Is it the second or is the third? What is Y? Stand for 0. That is the important thing for Python. If you, in general, you probably are familiar with MATLAB or other softwares that are starting from 1, and no, Python starts from 0. So if you put the colors, the second, 2, 2, 2, it is not the second for Python, because Python starts from 0. So 2 for Python is 0, 1, 2. So it is the third. And so this is our green, that is the third element in our list. In order to print the second, I need to put colors in the bracket 1. And the -1 is the last. So -1, it is just the last in the list. We can also do some slicing, and then I will put something more interesting. Not much, but... So slicing, and we can print colors, and from 2 to 4. And then also print all the colors from 3, and then just avoid the second index. Or we can also print colors with nothing in the first and then 2 at the last. And also print colors with this, with a -2. Can you imagine what happens here? You see that we have a slicing, so a part of our list. Not all the list, but only part. Part that is defined by our indexes. So you see that we have here written colors between 2 and 4. So we have already understood that 2, it means that for Python is 0, 1, 2. So it is our green. So starts counting from green. So puts green here. And then until 4. So 2, 3, that is the black. And the number 4 is not included. So you put the index of the first that is included, the last one is not included. If you print from 3 and above, you can see that there is the third, it is black. So it is black. So it is black and white. And if you put just the nothing and then the column and then 2, you start from the first one. So you start from the red. -2, you see that it is from the end. So you start with a white. I do apologize. You start, yes, -2. So you start white -1, -2. -2 is not included and includes all the others from the beginning. Any questions so far? So I would like to say that we can obviously modify our list. So our list is not, there are the square bracket. No? So with the square bracket we can modify the list. So we can say that, for example, colors 0 is no more red, but we want to put a yellow. So I put here just yellow and print again the colors. And you see that our white, it is replaced, hopefully, by the yellow here. I would like to, obviously the list can include numbers and character and so on. But we have, in general, in our calculation, it is very useful to have matrices. How to have matrices in Python? Or in basic Python, it is quite difficult. It is because these lists are just a collection of elements. But matrices for us is a structure, no? So in general, we use a tool of Python, and we need to import this tool that is a numerical calculation in Python. Also, the pi number is not available in Python. All these things that are very common are not available. We need to import a library that is in general NumPy. Numerical Python. How to import NumPy? We need to import, we can import in all the points of our file, but in general we put this import at the beginning just for convenience, just to know that we are using this, and we can import at the beginning, import NumPy, and in general NumPy is considered to be long to be written, so in general we import as np. So here we can, is it fine for everybody, this instruction here? Import NumPy, numerical Python, so it is the name of the library, and we import as np, so we use np instead of NumPy. In this way we can define the matrices, so we can, for example, a matrix, they are called in NumPy as array. Array, so we can say array A1 equal, and then np array, and then we open the parenthesis because it is a function. And then inside we define the matrix. I would like to put a simple matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 in three rows. So we put one row for after each other. So the first thing that you need to remember is that in Python you need to put as many brackets as the dimension. So we want a matrix with 3 rows, 3 columns. So it is a 2-dimensional matrix. So we need to start with 2 brackets. And the first is for the whole matrix. The second for the first line. And then we put the first line, 1, 2, 3. Then we close the first line, comma, we put the second line, for example, 4, 5, 6, we close the second line, and then the third line is 7, 8, 9. And then we close, and then we can also show, print A1. And then run, and you can see, hopefully, there is an error. I do apologize. Because you open 2 brackets, but you need to close also the 2 brackets. So also there is an indication of the error when I'm saving, okay? You see that there is a matrix here. And hopefully also in your computer. Are you all okay? Yeah, you know that these kind of things are objects for Python, so we can also include some here. So if you put A1 dot tab, you see that there are all the methods that are associated with the object. The object is the array. It is a little bit tricky at the beginning because you need to put here A1, the name of your object, this is for array, but it is for all the objects in Python. Everything in Python is an object. So the name, and then dot, and then you need to press 2 times tab, tab. And sometimes it's working, sometimes no. It was working before. Okay, now it is here. So, and you see that all these types, for example, we can focus on the first one, A1 dot big T. What is this? It is, we can say, print. Hopefully it is working, I don't know. T. You see the effect of putting A1.T, applying the transpose method to the matrix, to the object. So the columns becomes the row, and the row becomes the column. So they are changing just this one. I would like to show to you some control flows that may be useful in the calculation. There are also many methods you have seen for the arrays. I would like also to show to you some control flow. So I put here control flow, and I will start with the construct of the typical if. Else if in Python is elif, and then else. So I'm putting a equal to 2. Okay. And then I'm saying if a is equal to 1, you say it is false, so it doesn't matter. But if in case a is equal to 1, then do something. In order to say then do something, we put a column. So we put just a column here, and then we can say print 1. And then you see that I'm not putting any semicolon at the end and so on. In Python, they are not needed. They are. And then, you have seen that Python has not at the end, and has not the parenthesis in order to delimit what to do if there is a condition. So you see that also your software has put the indicator, no, not in the first column, but with a little space, an indent. There are 4 spaces, but can be also 1. It is useful. So in order to understand how it is working in Python, you need to understand that Python has not an end if is not needed, because it is just the alignment of the instructions. So you see that if a is equal to 1, I print 1, and then I don't want to do nothing else. So I'm going back to the first column, because if I'm continuing to follow this alignment, it means that all the things that I'm writing there are done when a is equal to 1, but I wanted to print just 1. So I'm going back to the first column, and I say elif. So for example, a equal to 2. You see, equal in this case, it is just a comparison between the value of a and value of 2. And then I want to print 2. And then if the number is different, so we can put else, always the column, and then we can say print. It is not 1, it is not 2, it is a lot. If we do this, run, you see that the printing is 2. because we put A equal to 2. If we put 22, it is saying, hopefully, a lot. Yes, it is much. One thing that is sometimes useful, it is also the for instruction. So I put here for range, and then I say for I in range 10. Oh, I do apologize. And then the column. What does it mean? It means that what I am putting here, it is repeated for all the numbers in 10. So starting from 0. So 0, 1, 2, 3, and so on, and so forth, and so forth. And what I'm doing here, I will print just the index. So I print I. So if you print I need to put this print in a little bit now with the indent, no? Because we are inside the range. If I print this, you see that it is printed 0, 1, 2, 3, and so on until 9, because they are 10 elements starting from 0. There is also the last one construction that may be useful in the next section, but not all. It is while. So the construction while, and for example I can say while the absolute value of a number, for example number z, is lower than, for example, 100, I'm doing something. Obviously, in order to work, I need to define z at the beginning, so I put z equal to 1 plus 1j. So it is a complex number, 1, 1, real part, imaginary part. And then I put here, and until the absolute value is lower than 100, I'm doing an operation, z equal to z square. How to put square in Python? It is double times. So it is, I need to find this. So this, it means that z is raised to 2. And then it is plus 1, for example. And we can print z, and we can also put something complex, more complex here. So while the absolute value of z is lower than 100, we do this calculation, we print. But if the imaginary part becomes lower than 0, negative, for example, we can stop the while, and in order to stop, we put a break. So break is in general associated with while. We do something with the condition. So when the condition is true, we continue to do these instructions. But if happens that the imaginary part here of z is lower than 0, we stop our iteration. And then at the end we can print the absolute value of z. I don't know what happens, because probably I create a mess with all these things. So you see, starting is doing this calculation and so forth, and then when the imaginary part is negative, it breaks and stops this while, and that is very dangerous. I would like to put some other two instruction for the array. There are something that is a little bit tricky, but it is just a curiosity. It is the identity. What is equal? And I will put A equal to 1 and B equal to 1 point. So it is the same number. If we print A equal to B, we will get a result that is true. I mean, A is equal to 1, B is equal to 1 point, dot. It is the same. But we can also print in Python A is B. And you see that the result is, I don't know, it is difficult to anticipate the result because there is always the risk that it is something is happening that is not so good. But you see here that the first is true, so A is equal to B, but when we ask A is B, so the identity, I mean, it is false because we have just put this dot. This was just a curiosity. And I put here, I would like to say something more about the arrays. So here, so we have already introduced the arrays with NumPy. We can say A equal to np.array, and then open and close the parenthesis. In this case, I will put not a matrix, but just a vector of 0, 1, 2, 3. And then I would like to print type of A, and then print also the dimension. So in order to know the dimension, it is a method ndim of the array, and we can also print the shape, a.shape. So all the properties. We can print also the length of this vector, so len of A, and we can print also the type. So the type of numbers, no? So D type, dot D type. Without L. Can you see what I'm printing? There? Is it is too small? Can I try to enlarge a little bit? Then it goes too much large. Okay. It's better? So we can run and see the results of these things. Unfortunately, when I'm enlarging too much, it is becoming large also the screen. But you see that the type of A is NumPy array. The dimension ndim, the dimension is a vector, so one dimension, matrix 2 dimension. And then the shape, and we have 4 elements, so it is 4. And then the length, it is, 4 elements. And they are integers, so it is integers, the D type. I'll put something different here to say that I'm writing A equal, again the same as before. I'm just repeating np.array, and then opening, closing. and then this is 0, 1, 2, 3. And these are integers, but sometimes I wanted to do some operation with a matrix with complex numbers. But the matrix that I'm starting, it is not complex. Many times Python gives an error or a warning, complaints, because you are multiplying things of different types. So I can force Python to say that these are complex numbers. So I will put a comma and then d type, and then equal to complex. So in this way, you can see that when we print A, we will see that it is a complex number, and we can also print just the imaginary part that are for sure 0 because it is a real number. I need to recover the run. I do apologize, here was not plus, was equal complex. I do apologize. No, still error. After 3, this parenthesis is not the appropriate one, is a bracket. Thank you so much. So you can see after, you see here that the numbers are becoming complex, and obviously the imaginary part is 0. There are some special matrices that in general we use or we want to use, I don't know, in this laboratory. For example, a matrix full of 1. Oh, it is quite common. So there is a method in Python to write this that is just once. So np once. np once, it means that the array will be full of how many, and we need to say. And so open parenthesis, close the parenthesis. Inside the parenthesis, we need to open again and close again the parenthesis 3 by 3, for example. So in this way, we obtain a matrix full of 1 with 3 columns and 3 rows. These are, it is a method, no, in order to put the numbers of rows and columns, no, 3 and 3. 3 the rows, and we can say also 5 and 3, and we can print.
Similar such comments are there in MATLAB also.
Yes, yeah, it is. And so these are the, makes Python familiar to those that are, using also MATLAB and so on. So you see, there are the full of ones. We have also for the zeros. You imagine what is the we can say M0, a matrix of zeros, so NP zeros, and for example, again 5, and 3. There are a little bit more parentheses, but the construction is the same. And we need, we can also print a matrix, the identity matrix. In general, it is called I. So this is the idea also of the name of this matrix, that is I. And for example, I5, we don't need here to put rows and columns because identity matrix is always squared. So it is, but I don't need a plus, but an equal here, and then we can print an A big I here. And we can also put another that is, I don't know, D, matrix D, diagonal, so NP dot diagonal, open parenthesis closed. We can put in the diagonal, all the other elements will be 0, 1, 2, 3, I don't know, 4. So we can print also this. And this is that. So these are the types of matrices. Oh, I have made a mistake here. So Where is the mistake? I put here diagonal. It is indeed, it is not diagonal, it is diag, only diag. Was run. You see the diagonal matrix here, the identity with the diagonal all 1, the zeros, and the matrix 1. I would like to put some basic operation with these arrays, and the operation can be oh, I don't know, some operation, so operation can be, for example, print of a matrix A multiplied by 2, or for example, and we can print also the matrix A plus 1, all the elements, and we can also, A is here, I don't know if you remember what is A. It is this vector, and we can create another vector, B, of ones, and 1 row and 4 elements. So we can print A times B in this way. So you see that by multiplying by 2, we just double the elements. Of course, 0 double is 0, and then 1 it becomes 2, and then 4, and then 3 it is 6. If we add 1, you see that it is just added 1, and then at the end we can multiply the 2 vectors. But you know that there is another multiplication, another product between arrays that is interesting. That is the internal product, no? The scalar product between obviously vectors. So the row to column product. So we can see here, for example, C equal to NP once and 3, 3. So we create a matrix full of ones with 3 rows and 3 columns. And then, okay, we can print C. And then we can print C, this symbol C. And we can compare the result with this kind of operation here. C at, no? Commercial A and C. What is the difference? We can see the results if there are errors. Okay, this is C, 3 by 3 once, and then I multiplied this all ones for all ones, so C times C, every element is multiplied by 1, so it comes. And then the last, it is this operation here, that is not shown here, with this symbol. So it means that it is not the multiplication element by element, but it is the row by columns multiplication. So the first row is 1 for the columns, every element is this 3. See, every element is this 3. The difference with MATLAB is that we have in Python a symbol that is different. In order to do the dot product, we use this symbol. This means the product, the row by column. We can also do the inverse, and I will just to put here, of the matrix, and A equal to NP array. I will just put a matrix that has 2 rows and 2 columns. So I'm opening 2 brackets. The first row is 1, 2, and the second row it is 3, 4. I'm closing the bracket here, and then we can do the inverse of this matrix. And in order to use this, we need to write the inverse function that is hidden in NumPy, because it is np.linalg.inv, because the inverse function, it is hidden in the part of NumPy that is associated with the linear algebra. In this way, we can put the inverse of A and also print data inverse, so we can try to find the run. Okay, it's going. So this is expected to be the inverse of our matrix. In order to simplify, sometimes writing all these things on np linalg inv, we can do something at the beginning. So we can go at the beginning of the file, in general at the beginning of the file, we do this operation and extract the inverse function from the library. So we can say from np.linalg import, for example, the determinant of the inverse. So in this way, we have these functions ready. So we can go back into the file, and instead of writing everything here, so here we can comment this and write after inv equal to inv inverse of A. And it is working now, because I put at the beginning the import of the inverse. It is working now. I do apologize. At the beginning I made a mistake, because here we cannot use NP, we need to use NumPy. So at the end it is working, and apparently it is working in the same way. Do you have any comment, suggestion? Until now it is for you that you are following also in the back, is fine. I would like just to use the few minutes at the end of this just introduction to say one thing about functions. So we can define in Python, obviously, function ourselves. In order to define the function, we use def. So def is used in order to define the function, for example, the square. So we can define a function that takes the square of x, and column, and then we can say return, and in this way we have the return of this function, and this function it will be x squared. So we can say here that print the square, and then we can give a number of this x, 5, hopefully. This gives 25, so we can group many instructions in this function. And another thing that I would like to show to you, it is the class. I've said before that Python uses objects, no? So collection of objects, everything is object. So we can create also our object here. And in order to create an object, we use a class. So class, for example, the car with the column, and then we need to define the object. So there are the functions. So the functions are the methods applied to the object. And the first thing that it is mandatory in Python to initialize the object, so define the basic characteristics. So there is a specific function that needs to be included in all the object specification, and this function, it is init, initialize. So we can say def, and then it is a little bit trickier, initialize init 2 times. So you see that there are two low cases here, no? So it is not only 1 but 2. It is 2 init 2. This is an indication to Python that it is a data specific function that initialize. So this is mandatory for other things, no, square and so on. Before we can use all our fantasy. For this, in order to initialize the object, the name of the object can be whatever you wish, but the first function needs to be written in this way, and the arguments are always start with self. That means that the object needs to know himself, and then we can say, since it is a car, it is brand or color. We can close double. So we put in self, it is the object himself, brand equal to brand, and self dot color, it is equal to color. So we have we can say it is enough for this object. We can also put another function, define, describe, self. So we can print all these things. We need to put the column, and then return. And we can say that for example, return, and then we can print. So in formatted way, we can start with F, discard, is a, and then in parentheses, in braces, we put what we want to print, and this is self dot color, and then the brand, in braces, self dot brand. These braces are required just for printing in formatted way this instruction. We close this with these things, And then we can say here, I don't know if you have a favorite car. We can say that my car equal, what is the brand here in India? I don't know. Tata. So we can call our object, so you see that the car is the name of our object, and we put in parentheses. Obviously we don't put self, but we need to put the brand and color. So here we can put and then red. I don't know if I am a mistake, and then we can print the object. So print the function inside the object. We have put a function that is described, so we can say my car, because now self, what we have called before self, it is my car. So it is my car, dot, and then we put our function that is described. So we collect the result of this function here in this print. So we can put here. The only thing is that you see that described as only self. So there are no arguments, but Python wants to keep the same structure. So even though this function has no arguments, you need to open and close the parentheses. So you see in Python many times this kind of writing. That means that just the function does not have any arguments. And then I need to close this, and try to run if it is there. Apparently, yes. I don't know, probably for the time we have reached our destination.
Yes.
So we can use this instrument. I don't know, hopefully that this hour it is getting you familiar with Python and Python Anywhere. So tomorrow we can do some very easy calculation by using this tool. Any question?
Sir, what is the difference between using Google Colab and Jupyter Notebook?
Yeah, I've tried to use Google Colab also, and so on. I found it much difficult because it is you need to have the account and so forth. This is quite easy because you have seen that by opening just the registration, it opens, and this file, you see that it is saved, and you can find also tomorrow. We will not use this file, but you can find here. It is here.
They use tomorrow because it is in the free version. Is it like that?
Pardon?
They have registered in free version. That's why tomorrow this cannot be used, right?
No. It is the free version allows to you a lot of space, megabyte here. So it is in my directory, because I put in directory GIAN, it is there, and mine is a free version, so it's still there. Probably we will not.
In your laptop. Same with Colab also.
Yeah.
You can log in with your Gmail account.
Yeah.
All the files can be saved in Google Drive.
Yes, in Google Drive, that there is this kind of things, so I prefer to use this because it was a little bit easier.
These files?
Yes, of course.
Yeah.
Yeah.
We'll share this.
Now I'm just can do my.
So there's a long day break. So we'll again meet tomorrow. So tea is outside. You can have some tea.
Oh,
Thank you,
thank
sir.
you. Thank you to you for your patience, because
Your tireless speech.
thank you so much.
So we'll again meet tomorrow 10 o'clock. our lecture will start at tomorrow 10